perspective, it is agile, strong, soft, dynamic, self-repairing, self-building and completely silent in operation. The goal of the Roboy project is to advance humanoid robotics to the state where its robots are just as good as a human body.
Seid ihr alle soweit? This? Alright. So, what you can see here is Roboy 2.0. It's the second generation of a humanoid robot called Roboy. And it's a very special project because the Roboy is probably the most humanoid robot in the world, as it doesn't have a motors in the joint as is normally the case, but it actually imitates the human muscle-skeletal systems. So it has muscles and tendons like the humans do, which is very interesting because it gives us some property for robotic systems that are very, very hard to achieve with classical actuation. For example, so this arm now is in force mode, so it retains a certain amount of force on each of those muscles, and it makes the whole system very transparent, so it can move it around very quickly. Or try a different industrial robot, or you can do a hand check, and this is kind of very natural. So this is super easy, and sort of the complexity that we pay is by having to understand and how to control this kind of system, having more than 9 muscles pulling on one joint, and try to understand how we as humans actually cope with this, because we are pretty good at that. So if you look at the human as a robot, we are amazingly good robots. We repair ourselves. We are super fast, very silent, we are very strong. We're really, really good robots, and we really would like to build robots that are as good as the human body. And you can see the movement are very fluent. They're not robotics like at all, because of the system, because of the softness that these springs in the system actually provide to the system. The whole system gets very fluent. Also, we are using agile methods to develop the system. So we are one of the few mechatronics team in the world that actually use agile methods to develop hardware. You know this all from software. It's very established, like Scrum methodologies, but they don't really work for hardware. So we created an adaptive framework, which is called Taft Agile Framework. Sorry, man. That we use to develop this in very small teams. So we have teams of about 4 to 5 people. We have teams of about 4 to 5 people that are developing these robots. Breaking up, yeah. So we have teams of 4 to 5 people that together with an agile coach and a tech lead develop certain aspects. And one of those aspects, for example, can be this hip. So this hip, it's not classically designed. So there was never someone that sort of drew this natural shape in a CAD model. It's rather that we just defined the constraint. We said, okay, this is about the size that we want. And here we have an attachment point, and there's a force of 200 newtons going this direction. We have a load from the top, from the torso, of about 60 kilograms. So we really need like 200 newtons. We have a bending moment on the hip of 140 newton meters. And we need space here to mount the motors. Please design me a part. And what it does is what you see over there. So it's evolutionary building. What's up with the cake? It's evolutionary building the system, and as you can see, the final part that is developing over time over there is just about 800 grams. And that's a very lightweight part for the part that sort of has all the forces in the whole robot centered. So we are talking here thousands of newtons that are coming here together. So this is for us a very valuable tool, of course, because the lighter you can build these robots, the faster you can make them with smaller motors, and the better they can interact with the world. Also, the robot has a face. And the question is, why does it actually need a face? Why do we have robots that have actually faces? And it's very simple. So if I... Let's build this layer. So, we actually looked each other in the face to negotiate the pass that my hand is taking, and to hand over the part. And this really helps in making sure. I think we have to switch the frequency of the this really helps in order to make sure that the handover is completely smooth, because we are expecting me to look at each other and basically giving you the flyer like this. For an industrial robot, handing out parts, like doing something like this, is exactly the same as doing this. But for us, it's not. We are expecting the person we're giving something to follow a roughly human path, and this makes human robotics calibration efficient. So, also, this robot has a dialogue system, so you can actually talk to it.
Hello, Roboy.
What's up, what's up, what's up? Mamma mia. So many people passing by today. Could you stop by to talk to me? Could you tell me your name?
I'm Alona.
I am glad to meet you, Loner. They chose to call me Roboy 2.0. I am pretty young, only 13 days old. I had been learning about doing the math and I made it. Robots are becoming more complex. For example, I evolved to recognize objects. My childhood dream is to become a robot rights advocate. Ask me some mathematical expression.
5 times 5.
So Lunar, 25. You know, in my free time I surf the internet. Sometimes I come across little stories that make me laugh. What about a joke?
Yes, tell me a joke.
Why are robots shy? Because they have hardware and software but no underwear. Wanna learn something new and interesting?
Yes, I want to learn something interesting that I have never heard before.
Dogs can be trained in sign language. In the future, I will be designing myself. I have started with a hip already, done by AI.
Yeah, your hip done by AI is pretty cool. It's probably the hippest hip that I've seen.
Is it not the hippest hip you have ever seen? I never travel alone. My team is always right next to me. What about you? Do you usually go traveling on your own or with friends and family?
I usually go with my friends travel.
Very nice. Did you know that people who have strong social connection live longer and happier? Keep it up, man. I have a joke for you. Do you want to hear?
No, I'm kind of tired. Let's talk later. Bye-bye.
Bye.
Alright, perfect. So what you've seen is basically a dialogue system that is comprised of 3 layers. In the topmost layer, we have a rule-based system that basically allows us to define keywords and key sentences where the robot can react on and then interact with the person. Also, in the second layer, it basically stores information in its own memory. So it knew that he was talking to Alona, knew certain facts. You can also query database